Hello world, my name is Lauren and I am the developer educator, or I'm a developer educator on the Vonage DevRel team, and you're watching my series, Lauren Learns Things, live on Twitch. This series is one where I learn things from my colleagues and friends and choose to share that experience with you all live on Twitch. So let me introduce to you our guest today. That is... Let's see, here you are. There you are, Kelly. And this is Kelly Andrews. He is a developer advocate for Vonage and has been tinkering with computers for over 30 years, using BASIC for the first time at age 5. It wasn't until building his first webpage in 1997 and trying out JavaScript for the first time that he found a true calling. He now fights for JavaScript, testable code, and fast delivery. You can find him singing karaoke very well, by the way, performing magic, or cheering for the Cubs and the Fighting Irish. Again, his name is Kelly Andrews. Kelly, welcome to the show.
Hey, how's it going?
Very well. Thank you so much for joining me today.
No problem. I'm pretty excited about this topic, so I'm happy to share it with you.
Okay, well, that's exciting. So take me through that. What are we talking about today?
Okay, so today we are going to talk about, at the core level, finite state machine. Have you ever heard of that?
No, and actually, I think your audio is still a bit loud. Do you want to pull that
Okay.
away from you just a teeniest bit?
Yep.
Yep. Those in the chat, if you want to let us know, I think it sounds better to me. So that works for me if it works for everyone else. But okay,
Right.
so
Let me know if I'm too loud for sure.
okay, so say that again. Finite state machine.
Yep. So a finite state machine is it's essentially it's an abstract machine that can be in exactly one state at a time. So state would be defined as if you took an application or anything, but we'll think of it as an application for now. If you took all of like the variables and the mouse positioning and the screen positioning and all that, that's a state, right? And an application can go through multiple states all at the same time and update and change. But at any given time, that snapshot is the only thing it can be, right? So that's what they mean by finite. There's only a certain amount of states that something can be in.
Okay.
So there's there's several examples, but one might be like take an elevator, right? An elevator, the doors can be open or closed. Okay. It can be on the first floor or the top floor. It can be moving. It can be stopped, right? All those different things happen individually.
Yeah, like it
Yeah.
there's no nuance of like it's both or it's kind of something in between.
Exactly.
Okay,
Right.
I'm with you.
So you can go from one state to another based off of different inputs.
Okay.
And which is called a transition, and we'll kind of go through those here in a second when we actually make a diagram.
Okay.
But essentially, a finite state machine is defined by its states, an initial state, all the inputs that trigger transitions, the events, and all those sorts of different things. And it gets pretty crazy, and there is so much out there information-wise that like we'd need a day and a half, not an hour and a half to go through it.
Yeah.
So we'll kind of keep the information sort of high level and introductory and not go too deep in the weeds, but we'll have some fun and we'll make something pretty cool by the time we're done. Okay. But essentially what we need to know is that it is made up of states, and then those states will have transitions into each other. So with that, a finite state machine can then be utilized in applications now using a node module called XState. So what we'll do is we'll work on defining an XState machine, and they have a nice tool called their XState Visualizer that will allow us to eventually see what this XState diagram looks like.
Okay. All right. I'm
but
with you.
before we get there, we're gonna go do a little bit of old school diagramming, and we'll use like Google Draw, and we'll actually just draw and think through some of these different things. Okay.
All right. So hopefully those of you watching are with me and understand so far some tidbits of what Kelly just said. Those of you in the chat, if you've ever played around with XState, please let us know, or what questions you have just from the intro he's given us so far. And if not, so we're both sharing a Google drawing pad right now, and we're going to visualize what this kind of is going to look like.
Yep.
Okay.
Yeah, so I mean, you can think of a state diagram as anything, even like an old flow chart, right? It's very similar to that sort of thing. It's organized in a hierarchy. It just describes what the state machine is, where the entry and exit points are, what kind of events and transitions can happen. So why don't we go through, and we'll make a real simple one to start with, and we will just make just like a button, right? So like a button has a couple of states that you could think of. What would those be?
On and off?
Yeah, so like on
and
off, right?
Pressed or unpressed. Oh, and David in the chat says that he's played with them a little bit. What have you played with in specific, if anything? But so far...
David Piano is the quintessential expert on... he wrote XState. So if anyone has the right to be nervous right now, it's me.
Awesome. David, welcome to the chat. That is incredible.
If I have any questions myself, we'll go to David and he'll let me know.
Cool. David, stick around. We need you, potentially. Okay, so let's see. So if I, what would you like? What do we need to see to visualize this? Just chilling. Love to see these. Yeah. Well, kick it. I have a seltzer, and let us know what points we might be getting stuck on. But also, like, if you see opportunities for cool things that we don't know yet, that would be really interesting too, or for folks in the chat.
I will certainly do the best I can. I do not know the same level he does. But
that is the best thing about our job, is that we are always learning. And David, confession, I've never played with this before, and that's why this series is called Lauren Learns Things. And let's do it.
So let's draw a circle for a state. We'll use circles as states for now, and then we'll connect these in a second.
Okay.
So make one circle. Yep. And that can be make some text inside of that, and just label that as your first state and call it on.
Okay. Great.
All right. So, and then duplicate that, and then we'll make a second state, and we'll call that off.
Okay. So do we, and this is just like for visualization pieces, so we don't need like color.
Yeah, it's not super critical now.
Cool.
Just trying to get a good idea.
Cool. So this is on, this is off.
Okay, so you have two distinct states for a button, right? Mm-hmm. It's on or it's off. And there's a way to get there though, right? Mm-hmm. What would you say you would do to actually go from the on state to the off state, or the off state to the on state?
I would close the circuit, or flip a switch, or take some action that would get me there.
Yeah, so you're gonna do some action or event, right?
Okay, event. So, that seems like a familiar word for me.
So they would transition between each other. So what we want to do is we want to show that transition using an arrow. So let's show that you can go from on to off first, and grab there's a curved connector arrow you can grab in the.
Okay.
You see it?
Yeah.
There you go.
Did I do that?
Okay, so make that one, kind of put that one on the top of it if you can.
Sure.
So we can see that there's going to be more than one.
Okay.
And then we'll put an arrow going one direction. And then we'll make another one, make it go the opposite direction.
I kind of want this to be a curved connector, like an arrow, though, because how do I indicate that? Well, okay,
let's see. I think you can do, okay, so when you click on it, there's two arrow things, that line end and line start, that come up.
Oh. Nice.
Part of this fun is learning Google Draw, so
yeah,
that's probably harder than most of it. So
nah, we could do this. We can do this. We can do this.
There you go.
That's nice. Ooh, will you make this
other one? All right, so yeah, so we can make this one.
Oh, I see.
I think it's gonna be other way. No,
other one.
I always guess wrong. Hang on. Okay.
Brilliant.
Off will go to on will go to off. Now, we can name these then as like an event name.
Okay.
Okay, so let's say we click something, right?
Sure.
And when you pass a click event, it will transition from on to off.
Sure.
And you can change that also over here. You can also click again, and it will go from off to on.
Okay.
Okay, now this is really rudimentary, right?
Yeah.
Just kind of getting the ideas. So you have two states, on and off. You have an event that gets passed, click, and it will transition from on to off. Okay. And if it's on off, the same event will click, the click will transition it to on.
Yeah, got it.
Does that make sense?
Makes total sense. I'm with you.
Perfect. Okay, so what we're going to do, what we're eventually going to get to is we're going to use a lamp.
Okay.
Okay, so there's a bunch of these that are pretty typical, and if you look through the documentation, yeah, if you look through the docs on XState, they use a street light a lot, which is really helpful, and because it can get pretty complex, right? If you think about a street light, there's green, right? So it'll turn green, it'll turn yellow, and it'll turn red, right? Each one of those are individual states. But then there's also, coupled with that, when it's on red, the walk sign, right, for the pedestrians can turn on and off.
Okay.
Those can all be timed, right? And it goes through a whole, each individual segment of the docs kind of shows how that grows. But we're going to stick with a lamp.
Yeah, it has two states.
Yep, and we can get through, well, it's got more than two. It sounds like it's got two, but we'll start with two.
Oh, okay.
We'll think through. This is kind of the part of the fun about states for me, is you start thinking through how this works together, right? And there's a lot more involvement than just the two. But at first glance, sure, two makes sense.
Right, two makes sense. And David just said that streetlights that's the hello world of it. That that definitely. Makes I like that. So pending, fulfilled, rejected. Yeah, I like that. Yep. That makes sense to me.
Oh yeah, promises are a good one too. Yeah, I totally agree. And that's there's the UI world. And the pending, the promises is really a good one for that, because that's more of a application development type, where what we're doing now is more of what a typical state machine would be defined as is more of an actual machine. You can even define like a car, all the states of an automobile. Those kinds of things. So I mean, there's you can define just about any machine with a state machine as long as it has a finite set of states.
Okay. Got it.
So eventually does translate into front end development, and the one that you'll see in the visualizer in a bit will show us actually the promise that he's talking about as well. So it's kind of cool.
Perfect.
Okay. So off and on is definitely good. That would turn on a light, turn off a light, turn on a light, turn off a light. What else might a lamp state be, though?
As in, like, turning on?
Well,
that transition piece, that promise piece?
No, not really. So, I mean, it may be, but what I'm looking for is the lamp itself, right? So the light can, but the lamp itself, may be powered or unpowered.
Sure. Yeah, electricity versus, yeah, sure. Got it.
You could have, it could actually be plugged in, or it could be unplugged, right?
Yeah.
If it was unplugged, you couldn't turn it off and on.
Yes, I am like deep in the IoT of my apartment right now, and the plug to the TV, that is like such a constant relationship I'm developing with Alexa of like the plug on versus the TV itself or the lamp. Yeah, that's got it. Very familiar. Sure.
Yeah. Okay. So we could even let's take one kind of step up then, and we'll define two more states that are a little bit broader.
Okay.
And we'll call, I'll drive this one for a second.
Yeah,
Hang
sure.
on. So do plugged in, and we'll do unplugged.
Sure.
Okay, so there's a couple of things we can learn here from this, and one is when it was just on and off. Okay, these are what you would call an atomic state.
Okay.
Which is there's really nothing to it, right? It's either it's on and that's it, right?
Okay.
There's nothing else there. So that means there is no complexity to that state. There are no child. There's no there's no other child states that it could be in.
Yeah.
We can start talking about that here in just a second. What they are is just that's it. It's on, it's off, right? So it's
Sure.
atomic. It's that lowest level you can get to.
Got it.
So with plugged in, now we can actually say it can be turned on and off at the same time. So now that starts to become a compound state or a hierarchical state.
Yep, makes sense.
Okay. Unplugged, and we're going to ignore the fact that you could flip a switch when something's unplugged to change. We won't get crazy here.
Okay.
But even think through that stuff too. So we'll keep it simplified. But when it's unplugged, you can't do anything.
Nothing.
So we'll call unplugged. Unplugged is pretty much atomic. There's nothing else underneath it. There's no compound states that can go inside of unplugged. It's just unplugged.
Okay.
But if we look plugged in, that can actually get a little bigger. So I'm gonna change that to a square. Okay. And then, let me back to here and range, send it back. Okay, so now we have plugged in.
Got it.
And then we can take on and off states, and I'm going to change these to white so you can see them. There's too many things to click on and draw. All right, so I'm going to group these. I'm going to copy these.
Okay.
Maybe. Welcome to our Lauren Learns Google Draw.
Yeah.
Yeah. Okay, hang on.
Nice.
Oh, come on. Cannot.
It works.
Okay, so essentially,
You
what
want
I'm
it
getting
all to be in the plugged in
yes
rectangle is your.
So it's like that.
Yep, got it.
That's the plan.
Yeah,
Okay.
Yeah.
So now what we see is once it's plugged in, now you can actually do off and on, and then you can transition between being plugged in and being not plugged in.
Of course.
Right. So if we go back to the curve connector, we can add that to here.
The unplugged.
Yep. And then our transition would have different names as well.
And there's this like implied order of operations too, right? Because it's you have to do the plug-in first before you can move to the world of on and off. Like that's an important piece as well, that you have a required directional hierarchy there. Okay.
Right. So as we think through this a little bit more, this starts to make more sense, and we start to add complexity to it.
Yeah.
Right, because now let's say our lamp also has a radio inside of it.
Oh my gosh.
Right? Now you can actually now nest inside of being plugged in. You can start nesting different things to it. And we'll work through that in the visualizer because it's a little easier to do there.
Yeah.
But so as you start to build this out, right, we start to dig in and you can find all these different layers of complexity to go through.
Cool.
Like what would be, so we have like plugged in, we have unplugged, we have off and on when it's plugged in.
Mm-hmm.
Think about what's like another potential state that a light could be in.
Dimmed?
Dimmed is a possibility.
This is so triggering. This feels like you have the answer and I'm just like, it's a school.
Yeah, I guess I'm not sure how you normally do this, but I was just sort of...
No, I love the way you're doing it. This is great. Okay, so a light is either on or off. I'm sure everyone in the chat is like screaming at me right now of what it could be. David is
Dim is a perfect...
Oh, okay, you're okay with
right?
dim. You're okay with dim.
No,
what were the other ones you were thinking of?
Not exactly what I was going for. I'm just saying that like thinking through all of these different states is like is one of the first things to start doing.
You have to design and plan before you dive into the code.
Think about like a checkout cart system.
Sure.
Right?
Yeah.
All kinds of states that have to go through. Yeah, exactly. There's no wrong answer.
Right. I see.
Answer. Yeah, and it's going through like trying to set up. One of my blog posts was on our video, right? So we have Vonage video.
Yes.
And we have all these different states that it can be in. You can be disconnected or connected. You can go through publishing, unpublishing, screen sharing.
Yeah, audio, muted, be the subscriber. Yeah, sure.
All these different pieces, right? And they can be, each one of these little items have this different state that they can all be in. So you have to track all those. And as I was doing that in just like, React context, it got really, really crazy. And it was all sorts of if statements all over the place. It really got painful, and I started learning XState specifically to solve this problem.
For this problem of complex state of it being
something
nested.
that complex that you're thinking through and you're trying to solve for. It's incredibly difficult to just not only to track that in like a bunch of variables in JavaScript, but then you're also trying manipulate it, and then if you change the way it works, that gets even harder.
That's
where this
dicey.
Way
you're like, I'm stuck with this. It already has decided to stay this way, so it has to.
And you now this charting problem, you can sit there with 4 or 5 of you and figure it out, what states this all needs to go to, what transitions it goes through, how it gets from one thing to another, what kinds of things to track long term, all kinds of fun stuff.
I have a question.
So the other one that yeah, go ahead.
So, and this is you also, David, like what do you, before you kind of dive into you spend some time really in this place of the brainstorm of visualizing the design of it before you go, or is it flexible to be able to then add and modify, on top of it, depending on a new feature, whatever, while in it? From
the relatively limited experience I have with it, it's flexible enough to be able to change.
Okay.
It is one of those things you have to think about ahead of time a bit, because you want to have like an endpoint that you want to try to get to.
Okay.
So you start working through some of those things and you write it down, or I did I literally just started with like bullet points. It's like, here's like this would looks like this, and maybe this state has this, and pieces. And
I'm having
and then,
massive flashbacks to like an assignment in my coding boot camp. Shout out to Ada Developers Academy in Seattle, where we had to, as a group project, like design all the state relationships between like a hotel system of booking in, of are your rooms booked,
Exactly.
and I failed that unit. So I just need to declare it now. And I'm suddenly super nervous, and I was really excited coming into it, but now I'm
totally, yeah. That's because it's really complex.
Right.
I mean, there's a lot to think through.
But
So,
yeah,
I
and I
mean,
think maybe that's the point, is it is hard to hold on to all of those things. So if this is what simplifies it, then, oh wow, look at me just like throwing my hand at the camera. Sorry.
I think it does. I think thinking through a state machine really does help simplify some of these things, because you can really start to break down what what the states end up being and what they should be, and then you start to modify those. And it's always going to be a work in progress, because you'll start with a theory like any other scientific kind of process. Start with a theory, you work towards that theory, you find out that theory isn't working, you shift it and change it and move to something else. And, gotta be flexible, but
iterative.
Exactly. So
Okay.
So the one that I was looking towards, also including, was broken. Right?
Sure.
But at some point, the light's broken. It doesn't matter if it's unplugged or plugged in. It's broke, right? So it doesn't even matter. It's never going to have anything else. It's just done.
Like the bulb itself is out.
Like the bulb is done, or the electricity's fried, or whatever. So we'll just call broken kind of another one.
Okay.
And that will be a special type, and that will be one that will be what's called a final state.
Oh.
Okay. What will happen is anything that goes to broken, the machine stops at that point.
Got it.
So you would have to fix it and then restart it. And this is a completely contrived example, so it's just bear that in mind. This is not like a perfect solution to this problem. But if it breaks, then
and this arrow both go to the broken, right? Like on this, because you're never coming back from broken.
That's the idea, yeah.
Okay,
is that
got it. Got it, yeah.
Yep,
and you said that this is called the special state?
It is one of there's different types of states that we'll learn about a little deeper. One is final. The other one we've already learned about is atomic. And that is, it doesn't have to be declared as atomic, it just is or it isn't. And then the compound state, so this one here is compound.
That's a compound,
This one would be considered a hierarchical state. And then what we'll get into before we finish this part of it out and move on to actually building it and writing it, is what's called a parallel state. So when I talked about earlier, we had the radio and the light bulb. So I'm going to just overwrite some of this here for a second.
Okay.
So we have the light and the lamp and the radio in the lamp. So if this is the radio, right? So it would also have...
The radio is going to have an on and off,
as well, right? So that is the exact same as this plugged in state was, but now it's nested inside. Okay, and then I'm gonna kill this here. It's just getting in the way, and we will end up reproducing all of this anyhow. So, okay, so then what you can have is
your light.
The light, we'll call it a light, so it's not confusing.
And for those of you that are just joining us, Kelly's walking us through a visualization of, helping us think about a state machine diagram and the different states and events and kind of understanding the main parts in general, just of what we are going to be playing with today.
Yeah. Okay, so when we're plugged in, the light can be on or off, the radio can be on or off.
Okay.
be those at the same time. So this is, we said that it can be one state at a time, right? But when there is what's called a parallel state, those things can happen together.
Got it.
And it's a simultaneous thing, but the state itself is the plugged in part, and it's the variation. So at this point, you can be plugged in with the light on, the radio on, right? So there's those permutations of that.
Got it. Makes sense.
Still technically one state. It's just how you represent that one state is a little different.
That makes sense. Yeah, I'm with you on that. Okay.
So we have this final state here called broken. We have unplugged, which is an atomic state.
What's the difference between the component and hierarchical?
Okay, so the compound one can be parallel or hierarchical. It just depends on what if it can have like more than one at a time.
Okay.
So light and radio here are hierarchical, where it's either on or off, but never both.
Okay.
Right, so one takes precedence over the other. Okay. Where plugged in is parallel, and you have light and radio can both be functioning at the same time.
Got it. Thank you. That makes sense.
Yep. So, and then, we were talking earlier with David about promises and callbacks and all kinds of stuff. XState is a massive library that does an insane amount of really cool stuff that we won't be getting into necessarily.
Sure, we're just beginning here.
We can do a part 2 of these in a while, and we'll come back and do some other fun stuff.
That sounds great.
Let's look at. Okay, so this is more or less how this works, right? We can.
Yeah.
We'll assume that there are transitions between off and on. We have all the transitions mainly here. So what we need to start doing is actually writing a JavaScript object in XState that will show us a visualization of what this looks like. So are you...
So I have XState. I just moved over. If you look at my desktop, I'm on the XState, I think, the home page.
Perfect.
Okay.
Yep. So this is sort of the default example he's talking about, and this is definitely a like a fetch operation inside of a browser.
Yep.
So the nice thing about the visualizer is you can click through a state diagram that you've written. Okay,
which is this right here.
Yep. So if you look at what's blue and highlighted, you have idle, and then if you click on fetch, that's the action you'll send to the machine. Okay?
Oh, okay.
So now it's fetching something and it's in a loading state, right? So now you have a spinner or something on your UI, and then the fetch will either resolve or it will reject, right? So if you resolve it, it goes to success. That's a finished state. And that machine's done. Everything complete.
Yep.
Okay,
so then fetch, reject, and then it brings it back. Very cool. Okay.
Oh, bless you, David. Hopefully I can resize the code on the left, on the right.
Ooh.
That's been. I'm actually really giddy that he just said that, because
it's so fun. You heard it here first, folks.
Yeah, that's
sorry. What he's speaking about is in the chat. The brand new visualizer is coming in a few weeks.
That's good news. Yeah, it's a super powerful tool already. So whatever changes they're adding to it is going to be making it better.
Oh, cool. So CodePen like a sandbox. Great. That's awesome.
Cool, man. Thanks for that heads up. I really appreciate that.
Definitely.
Okay, so let's we're going to delete most of this. Okay, so go ahead and in between the curly braces of the machine function, everything from that curly, just delete all that. Yep, everything inside of there. So it should go pretty much down to that one. All right, so if you update that, try update, but it may just do nothing or give you an error. Okay, it does nothing. That's fine. Perfect. It doesn't matter. We're gonna add some stuff to it.
Okay.
And then we delete the comments above as well, so it gives you as much real estate as you can get.
Can I make this maybe larger for those in the watching?
Yeah.
How's that look,
That'd be
everyone?
great.
Okay. Okay, so all we have is right
Yep.
here.
So
Cool.
the first thing we're going to do is we're going to rename this, and we're going to rename this our lamp machine.
Yeah. Okay.
Okay, so the machine function, the machine method from XState, technically does take. I can't tell. It should. You have open and close curly braces. I can't really tell from here.
Yeah, I do. I'm trying to think of how I can make this larger.
That other one looked like a square bracket was all. I was just making sure it was.
Yes, parentheses and a curly brace.
Perfect. Okay, so we're gonna do. The first thing we want to do is you want to just give the machine itself an ID. So there's technically the machine method does take two inputs, right? So the first one is sort of the configuration of the machine itself. The second one is an options, which you can give different, like they're called actions and activities and services and guards. And we're not going to mess with it for this one. But know that once you kind of get this first part under your belt and understood, the next piece.
It's a boilerplate or like similar to.
Yeah, it gets so much better and so much more powerful. But we're not really doing anything with actions or anything like that yet. So give this an ID. So the first one is just ID colon, and then we'll give it an ID of lamp. And this will give us something that we can reference later if we need to.
Okay.
Okay. Now, one thing about a state machine is it always has an initial state. Okay, so if we think back to our diagram, we had three main states: plugged, unplugged, and broken.
Plugged in.
So easy, and I mean, like you pull one out of the box, it's unplugged, right? So the initial state would be unplugged. So it would be.
How do you want me to write this? Sorry.
That's okay. So it's actually initial. Yep. And then it will be just unplugged, and it is in quotes. So spring unplugged. Yep.
Okay.
Cool. Okay, so now what we're going to do is add a comma there, and then we're going to define the states that this machine has.
To the after the ID, right? I need both. I skipped that.
INDIAL, initial.
Ah, there it is. There's her dyslexia. We missed her. Okay, found her. Okay. What did you say next?
We're gonna do states. So STATES.
I make the same mistake. Yeah, well, David, me and the stream are typos. It's just the chat is lovely for this because they catch it, and it's like group debugging, and it's always that, and it's usually in my environmental variables, and I have to show my secrets on the screen. So that's just some context for this. The audience expects that I'm going to be rotating my secrets every week because I show them so often. Okay, sorry. So states, we have we have to list out the states that we have available.
Yeah. States is an object.
Oh. Okay.
So states actually an object, and you're going to have multiple items in this. So
sure.
You were right. You were on the right track. So go ahead and hit return, and then we're going to do our different state nodes here, which is unplugged.
Okay. So, but within.
They're each going to be their own individual objects.
Okay. Do I have to do any where are we on the indentation world?
So you're going to move in one. You're going to tab over. There you go. All right. So then do, just for now, we're going to kind of stub things out. So do colon and then open closed curly brace.
Okay. And then comma, next one.
Yep. And then the next one is going to be plugged or plugged in.
What do you want plugged in?
I did plugged in with a capital I. Yep.
Yep.
And then open close, comma. Yep. And then broken. It Okay, so
I can't see I know.
And so the states is it is an object, so it has to have an open and closed curly bracket. So
yeah.
So right after the colon, add a curly brace there, and then hit return there, and perfect. All right,
I
now
keep
hit
wanting to hit
update.
save. How do I save? Oh, you read my mind.
We'll put it over there.
I'm
Okay, so
feeling
see,
nervous. Oh, it is there. Okay, because we didn't see anything at first, but now I see my states.
yeah, so now we have
It's not
three
that exciting. It
individual.
should be that exciting.
Yeah, YAML wouldn't awful. But I don't mind the
Sorry.
JSON, but yeah, the YAML, David, that would be an interesting addition too.
Yeah. Well, it's really funny because yeah, no, never mind. Just this stream, we have usually we write in a different language each week, and you can see when I have fall over from other,
yeah.
but that's what keeps things interesting, and it makes it so that we pay close attention to my syntax actually. So it's good, I think. Okay, but no, that looks great. So we have right here, folks that are just watching, this is right on the left-hand side of this, we have our 3 states. And then we see that the blue is highlighted because that is the current initial state that it starts in.
That's exactly right. So when you start the machine, it is currently, it's unplugged, right? So that's the initial place it is.
Yeah.
Okay.
You hear what I'm doing, right? That I'm like rephrasing it to make sure I actually understand
Absolutely.
it. Okay,
That's
okay.
That's the best way to learn it. Okay, so in broken, let's go ahead and hammer that one out because it's pretty easy. So we're going to give it an ID as well.
Okay.
So give it an ID and name it broken.
Okay.
And then we're going to give it this one a type. Okay, so give it comma, enter, type. And that one is, in quotes, final. So, yep, final. And then go ahead and update that.
Final. Oh, right. I remember. That's one of the types of states it can have.
So now it's got that little double.
That indicates that. Okay.
Outline. Yeah,
Cool.
indicates that's the end of it.
And then will we give an atomic state to unplugged?
Yeah, so sort of. Let's go ahead and start with that one now.
Okay.
Okay, so give unplugged an ID as well, and we'll just name it unplugged as well. And the reason for the IDs is when you're adding stuff, it's actually super easy to navigate through those and to call them out because they actually have an ID that you can reference later. So, okay, so when it's atomic, you don't actually have to declare its type at all. It just is. So we don't need a type.
Can I just delete that? Yeah, okay.
Just delete that.
Okay.
Okay. And then what we'll do here is we're going to define the actions that you can do with unplugged. Okay. So the way you declare actions are with an on property. So do comma and then enter and then on. Yep. And this is actually an object. So open and close bracket, braces, curly braces.
Got it.
And then, now the standard notation for an event is all caps. And then with, it's like the underscore for spaces. I know that has a technical name, but I can't.
Oh.
I think they call it shout case.
Okay.
Okay, so we'll do one event called plug in.
And then
it's
this
all
is
caps.
what you're saying, underscore.
Yeah.
Okay. But in quotes?
And then, nope, it doesn't have to be in quotes.
Cool.
And then we're going to do a colon here. And when you plug that in, what state do you think that goes to?
It goes into plugged in. It changes the state.
Yeah, so in order to represent that transition, the simplest form of a transition is to go to another state. So just put in quotes the name of the state.
You can do that. You can just say plugged in.
Yeah. Now, when you start getting into more complex state machines, this actually can become an object, and you can have a target, and you can do other actions at the same time.
Okay.
But we're not going to go that deep into this one right now, so we're just going to transition between states really easy like that.
So I updated it maybe too soon, but I'm just now seeing if I press plug in, it becomes plugged in.
The plug in. Perfect.
Shocker. But no, that is interesting. Okay. Okay.
Yeah, and that's the great thing about using this tool is that you can see
Yeah,
this happen
that is cool, actually.
as you go. Okay,
Wait, can
so
I
there's
just
one
press
other.
this really fast and see what's over here in state?
You can look at it too, sure. So
Oh,
this
look.
actually, so this gives you
Okay.
the state information that you actually need, like the current value. If
Cool.
there's also
That's
a
helpful. So
longer.
you can see what's always the state at
Exactly.
different. That's cool. David, that's cool.
As you really, really, really complicated,
Yeah.
you have a growing
Of
state and you have
course.
contacts and
Oh
all
my
kinds of
gosh. I love it. This is awesome. Okay, neat. I'm in. I'm hooked. Okay, so now what else do we need? We need, plugged in moments, right?
stuff. So we're almost. What other?
Oh, yeah.
We have one other transition from unplugged, right?
It's broken.
It can be unplugged and go. Yeah. So if we go, let's add a break event.
Oh, okay. Yeah. Oh, and it's this
It's a
outside of.
nope, same one.
Oh,
So they all the actions that this, all the events that this and transitions that unplugged can take.
got it. And it's going to be broken. No, no, no. What did we call it? Broken?
So if we go to broken.
Yeah.
I use a let's update that. It should fail, and I'll show you why in a
Okay.
second.
Update.
See if that works or not. No, it actually works. Okay, so when they're top level siblings like that, it typically works. But as you start to get more nested,
Yeah, what's a better form or better way to do it?
when you get more and more nested, you can use a hash, the
Yeah.
hash symbol,
That makes sense.
and that will call that specific ID broken. So what happens is in a minute you'll see it more when we're in like light on and off, and you want to go to broken at that point. It's like it gets really weird because you have to be able to call broken at the top level, and it thinks you want to do siblings basically for the most part, unless you start calling these specific IDs. So there's all kinds of different ways you can do it, which
Okay.
it lends to the flexibility,
Sure.
but also complexity of learning. So it's but the pound sign will always go to like an ID of a specific state. So you can always
Keep it within quotes?
yeah,
Okay.
yeah, just like that. And it's really not super important here, but as you
It
learn,
makes sense this is the conventionality. Okay.
yeah, it can get into that. And there's
Okay.
different types of transitions between, like, you can do ones that are internal, where it only goes in between a specific state, or if you have
Okay.
ones that are what's called transient or automatic. There's all kinds of different ways that you can approach those types of things. So as you start to get more and more comfortable with it, the documentation really lays it out there really great. So,
Okay.
but we'll keep it simple.
Okay.
Okay, so now unplugged has two actions. You can plug it in or you can break it. Let's define plugged in. So let's start like everything else. Let's start
Give
with
it an ID.
Yep.
And this is plugged in. And then we need to give it another on? Like we did before or no?
Almost. So before this was a this was atomic, right? It was like plugged in or not plugged in. But now it's a compound state,
Right.
and this one was parallel, right? So if you
Yeah,
look
we
at
had the two because remember we had either the light or the radio.
yeah, so let's look
How
at
do we represent that?
so do a type here. Okay, so type what type was
Yes. Okay. Parallel.
Yeah,
Okay.
that's the one I always misspell.
Ah.
So now inside of here, we're going to do the states that are available for plugged in. So do comma, and then we're going to do another states object.
Okay. Okay. And then here we're giving it like we need to do radio, like that.
Yep. And then just make them open and closed for now, and we'll come back.
Oh, okay, sure. And then we also have the light. Is that what we called it? I think we did. Yeah, light and radio. Okay, so we have now two states because before we just had the states could be unplugged, plugged in, broken, but now within plugged in we have multiple states. Okay.
Yeah.
Cool.
So that
I'm
becomes
there.
compound. All right, so if you hit update, that should update the chart again.
Ooh, oh my gosh! And it looks really similar to what you drew or had us draw. That's really awesome.
Yeah, it's starting to take shape, right?
Yeah, this is great. Okay, so now we need to somehow connect.
Before we go there,
Okay.
let's define when you're plugged in. There's a couple of events that can happen, right?
When you're plugged in, you can either have the light on or off, or the radio on or off, or the whole thing be on or off, right? Or unplugged.
You can unplug or you can break from here. Okay,
Yeah.
So let's define those real quick.
So that's before the state, or should we do it after the states?
We'll do it right after the states. So
Okay.
the states will be the one part, but the plugged in state itself can now have actions be called on it. So if we do on,
Yep.
and then
And it's going to be an object of, it's going to be break and unplug, right?
that would be good.
So is unplug one word?
I believe so.
Yeah. Because we have plug in, it's not plug out.
Yeah. Unplug, and then that's going to go to
Unplugged. Oh my gosh, this is so funny. The word plug doesn't sound like a real word anymore. I'm like in that space.
Right.
Okay, break is going to be similar to what we have right there, which is just broken. Okay, update.
So update.
Ooh.
Okay, so now you see how that works. So it's not that from radio or light get broken. It's when it's the lamp itself, when it's in a plugged-in state, can be unplugged or it can be broken. You could go another layer and look at like the light itself can be burnt out,
Of course.
or broken, like that kind of thing.
Yeah.
And not get too complex
Okay,
with that.
yeah. But I see what you mean. Okay.
Like yet another layer to start looking
Of course,
into.
it's so fun. Okay, so now we need to do the radio and the light. Are we ready for that?
Yeah, let's do radio first.
Okay.
So radio with an ID.
Yep. Okay, and then it's gonna get.
Now every state needs an initial state, so we'll just start it in one of either off or on if you want.
So initial, I forgot. Right. Okay. So do I need to do that outside of this piece?
It's so radio. This is where things start to get fuzzy. Right up till now, it was pretty.
Yeah. Okay. Hold on. So I'm just gonna follow the pattern up above where I give it initial. Right.
That's fine.
And it's gonna be on.
Off.
Off.
On,
Yeah. Off.
Off makes sense to me, but.
Did I spell initial incorrect again? Yeah, I did. Yeah. Initial. All right.
There you go. All right, and then put an ID in there above that.
Okay. Yep.
So
Oh, I
because
thought
each
I
one of-
had that, but I just okay. And this is radio, and then comma. Okay.
And each one of these things now are their own hierarchical compound state.
Exactly, but we don't need to declare that type.
Right.
Right.
So, okay, so next we want to define the states for radio.
Of course. And so now that's going to go after initial, we're going to go states, and that's going to be its own object. So I'm going to drop down into it, and that's going to then be, what did we give it? What did we do before we did unplugged, plugged in, or broken? But right now we're just doing on or off, right?
There you go.
Okay. On, let's just
and then just
off
yeah,
for
you got
now
it.
because I feel like that's the good pattern we've stuck to. Okay. Okay. Wow. You know what, Kelly? This is so interesting. I'm zooming out and thinking about it from your lens of explaining this to someone. And there's some complexities there because this is
It's
pretty
crazy.
long, like not yet that long, but you can see how it would get really. And so taking out each nested piece and building it out, you're doing a great job. I haven't felt overwhelmed at all. So it's really, yeah, it's
Okay, good.
interesting.
I'm completely over.
Oh, okay. So
Oh, no, we're fine. I'm kidding. I have a cheat sheet. So,
Okay.
All right, so hit update, and let's see what that change does to it.
Sure. Aaron says it'd be so nice if the definition supported JSON 5. Okay, so.
Is that like the Jackson 5? No. Sorry.
Oh, wow. He's on a roll.
I don't know the JSON 5. Look that up. I haven't heard of the new definition. JSON 5. Oh, it's human readable now?
Has comments,
Interesting.
etc.
I like it.
David, you heard it here for. Oh, look at that.
I had not heard
cool.
of this yet. This is cool info.
Yeah.
I'm so neat in just regular JSON that I don't even.
I know.
Thanks, man.
Yeah, thanks, Aaron.
Thanks. That's really helpful.
Yeah, well, we agree. All right, so we were giving, okay, so I see now looking at our visualization of it that we have, you see that it's really coming to this place of looking parallel to that, which is really cool, first of all. But second of all, we need to give the state, we need to tell it what to do when it is on. We need to either give it,
well, go ahead and on the visualization, click plug in and see what happens.
Oh, okay. Oh.
Okay. So currently, what we have when it's plugged in, radio is currently off. Light does nothing because nothing exists, right?
Yeah.
But what we don't have, like you said, we don't have those transitions between on and off.
Right.
Okay, so this is the only hesitation I had about using a lamp because on and off as states becomes a little confusing when you have on as the transitions and the events, right?
Yeah, because we need.
So just trust that it works.
I believe you.
So on the on state, okay. Now this one can get an ID as well. It's not necessary here.
Okay.
But just know that if you needed to, like the IDs and initials and all that stuff, you can another layer.
Yeah. Okay.
It can keep going pretty much indefinitely as far as I can tell. I mean, I'm sure it has a limit, but at least as far as like you get to a point where it's not necessarily limited by the library, it's limited by the logic of it. Like you've just built it wrong at that point. So
sure.
It would have to be a very specific reason why you would do that. But anyway,
okay.
So here we're doing actions, and again, it's on. So just know that inside of the state on, you have an on node here. Yeah, but it's not. It's actually not caps. So it's.
Oh.
There you go. Yeah. So on, and now we're defining what these transitions are. So the transition name, like the event name, can be the same thing. This is actually going to be an object because you're going to be able to define, you could define multiple events that can happen in here.
Okay.
So instead of string, make it an object.
Okay.
All right.
Yeah.
And then inside of here, what we want to, like, this is the radio, and a radio to turn a radio off and on would have what?
A button? Wait, what do you mean? A
So
switch? Yeah.
call this one specifically radio switch.
Radio switch, okay.
And that is
No. So this is, it is? All right.
caps with the underscore.
Yeah.
You need the underscore in there. Just don't forget that.
So,
unless you have it and I can't.
I do. I have, radio switch. And it is then... Right?
No, I just pixelated
sorry.
it to be invisible.
Great, exactly what you need.
Screen share. Okay, that is what would that go to then?
it would go to the state of on or
Well,
off. If it's on, it goes to off, right?
There you go. This is a transition from the on state
Right.
to state.
And then then it also has. Does the off then need the same for to turn it on?
Give that a whirl.
Okay, so this is just off again.
No. So that's where it's confusing.
Oh.
The defining the events is still
on. I knew it.
Yeah.
Dang it. Okay. And then this
The
is
reason why I have that on, because the off and on state it gets a little confusing.
And
but
is
just
it
know that
same? Is it same radio switch?
it has the same event here, and if it was
Okay.
in the off state, it would go to on, and if it was
Okay.
in the on state, it would go off.
All right.
Okay,
so
so
I'm gonna
update
plug it
that.
in, and then my radio is on off, but I'm gonna radio switch it on. No,
So
I'm gonna. Oh
you're in
wait.
the off. There you go.
Right. All right.
And I apologize for any children screaming heard in the background.
Hey, we're
We're clocking my
humans. I love it. No, it's not picking up at all. Don't worry, you're good. No, this makes total sense. And now we just need to do the same for light, and it's pretty much the same, right? But
It's exactly the same thing.
so what I'm gonna do is copy and paste this, and then just change out it to be light switch.
Sure.
Okay.
Sure. Now, before you change anything out, change the ID.
Yep.
Change the ID light. Okay. And then update it now. And I want to show you something interesting. All right. So if we can
Plug in.
there. Now, if you plug it in, and you click radio switch.
On the light or the light?
Either one. They should. Yep. They both flip to on.
Okay.
Because they're for the same event.
Right.
Right.
Right. That makes complete sense. And so
Just
here we.
Multiple things listen for, right? If you send an event
This
that
would even work. Right. So now it'll still okay. Cool. All right. So now, all right.
Okay. So that's radio. So let's change this back to radio. That's okay.
Wait. No. I'm in. Yep. I'm in radio. Shoot.
That's a fun challenge is traversing.
Sure. Light. Okay, good. Just double checking that I have all of them. Cool. So now let's give this a try. So we're unplugged. Plug it in. Radio. Well, we know radio works. So switch the light on. Switch the light off.
Yeah. Now see how
It's interesting.
See how they now work.
Yeah.
Pretty neat, huh?
This is great. And then if we, for whatever reason, we break it, it's over. There's no new place to go.
You can reset it.
Yep.
And if you plug it and then unplug it,
Yep.
plug it back in.
But we
Now,
can
here's
even do
one-
this at any point. We can unplug here. And do they still stay in the off position when you? Yep. Okay.
Yes. Now, should they? Now, this is where things get a little...
So that's debate. Yeah, I don't. Well, if you're playing with a regular old lamp, yeah, you would want the circuit. If the circuit's connected, when you unplug it, you would want, when it comes back on, you would want it to be in the state of on. I mean,
Hang on one second.
Come on in. Let's say what's up.
You got me the mail? Thank you, sir.
It's mail time. That's exciting.
Have all of his clothes on, otherwise I'd introduce him.
I get it.
We're definitely one of those, hang on, we may all be in our underwear kind of people.
Wild times. I get it. Okay, great.
A lot of boys. Okay, so if you, let's say you switched a light on, and this is, like it's a mechanical switch, and you have the radio on, and then you unplug it, and you plug it back in.
In theory, it should come back on immediately. The initial state.
So wouldn't it be great if there was a way for XState
To
to remember that.
Yes, it would be great.
So there's actually a way to do that. So there is a special case called history states. Okay. So inside plugged in, underneath.
Okay.
Yep. So follow the line from like radio and light. So the first indentation in.
Yeah.
You're gonna make a state underneath those.
Yeah.
So go down to light. So it should be that
right
second.
here.
Yeah, right there. So put a comma there.
Yep.
And then make one, just call it HIST for history.
Hist. All right.
And then we will a new object here for a new state.
Okay.
Okay, so this type is just history.
But do we need an ID?
No.
Okay.
No, we don't.
And the type is, what did you say?
History, and that's a string. Yep.
History has its own.
And then comma. And then underneath that, we're gonna. There's two types of histories. There's one that's deep and one that's shallow. It defaults to shallow, but I'm pretty sure in this case we need deep because it goes more than one level.
Okay.
So go ahead and do history deep, and I could be wrong with that, but it works. So
for now, we're keeping it.
yeah, I'm keeping it because I know it works.
Cool.
And that's it for that. Okay. So when you update it, you'll see.
Oh, that's
you'll
nice. That was easy.
State.
Okay.
We're almost one more thing to look at.
Hist.
Okay, so there's the history state. Now, when we plug in, instead of just going to the plugged in state, we actually want to go to the substate for hist. So instead of doing just plugged in, okay, so under unplugged.
Yeah,
Yep,
we don't want to go to when we plug in this line.
We want to go to. Yep, but it's a substate, so it's just like any other JSON object. You do plugged in dot hist.
Like that.
So go ahead and update that.
Wait, but
Okay.
this is only But when we plug in, don't we need that too?
And that's where that transition is happening. So when you plug it in, it will go into the history state as opposed to just the plugged in state, and it'll do all the initialization stuff or all the initial states.
Okay.
It'll go back to what it was before. So look at the visualizer.
Have I updated it? Okay.
And if you hide the code real quick, that might help too.
Sorry, what?
Click the hide button. There's a hide button
Oh yeah, got
up
it.
there.
Okay. Oh, nice. Okay.
All right, so click plug in. Okay. So now turn on the light.
Okay. And then
Unplug it.
unplug it.
Yep.
Okay. And now
Yeah.
plug it in, and light should be on. Woohoo! Plug it in. Plug it in.
So now you can store states from before in a history,
Okay.
which allows you to then go back to previous states of something just instantly, basically.
That was a lot easier than I thought you were building up for like, but you did that. You were like, wouldn't it be? Yeah, I see what you were doing.
Yeah.
That's cool. And that's the
All
only
right.
place I need to do that?
Yeah, I mean, you could.
Yeah.
If it was broken. It could
Sure,
go
the
back
broken
to,
you
but we
might
don't-
want to. Okay. Wow.
That's, and that's back and forth with these sort of state diagrams that you can do. You can sort of start in one spot and then go, well, that's not right. What if we added this? And then you develop that piece. That's the sort of iteration you need, I think, with this kind of thing. And if you were trying to just build this straight into a UI, it would be really hard, right, to keep track of all of these different pieces, what's on, what's off,
Yeah.
and then you have to add all the functionality, all these new methods to track all that sort of stuff, which gets just, really tedious and easily broken, very fragile, right? So now the nice thing is in here in events, you
Yeah.
can see
That's
what
so
you've
cool.
done, the
love that.
order, you can all the different pieces.
Yeah.
Now this is super straightforward as far as like how this can work, because you know, like in the video example I built out, which we can share with everybody here in a bit. We can share them the article, but
let's definitely do that.
You know, we have, you know, events. It's an event-driven architecture, right? So our video API is very event-driven. So we have callback methods that happen. So they actually will fire specific actions when someone turns audio on and off, or when a new subscriber starts streaming, or, you know, when a session dies or whatever, right? There's all kinds of things you can do with callbacks and pendings and new machines. You can actually spawn new actors, which I do. You know, I have a part 2 that I'm writing for it, and it's
for video. That's
for each individual video that comes up. That's a whole different thing that you can now, as an individual machine. You know,
cool.
So it's like this really just scratches a very high level surface and gets you started.
Yeah.
But then I built it into a glitch example. If you want to flip over to that.
Yes, let's do it. Okay, so this is the XState introduction. Okay, and
what you just built in the visualizer. But if you look at the script.js. So here's the lamp machine, pretty much where I was headed. So it's pretty much built the exact same way.
Yeah.
And
except that now we have here.
Old school JavaScript.
I see.
So this really made me miss React for a minute. I'm very much a React guy. This was like, oh, this is really hard to do.
Totally. Long-winded moments.
One thing you notice, well, you may not notice, but one thing you will notice after going through the code a little bit more is I never control what state I'm in. I never control,
because this is doing that. Like, that's this job. It's not here. You're just running some if statements, and kind of telling the front end like what it looks like. What state it's existing in. So that makes. I see.
So then, if you look at index.html real quick, you'll see some buttons.
Okay.
And those buttons have like radio switch and light switch. And I have a break button, and then the plug-in button switches based off of if you're plugged in or not.
Oh, this button here. Okay.
If you
then send.
Grab it and look at it. Yep. So send is a function that comes from the machine itself. So actually,
let me make this a little bit bigger for everyone.
Yeah, go back to the script.js file too. So scroll down to the bottom.
Yeah.
And there is okay, so scroll just a bit. The init lamp method. So what I do is I have this lamp instance, which is control, which I pass in that machine, and then there's a callback method, or like a listener method called transition, and that on transition will pass the state in, and then you can go through there, and then it tells you what this different state is based off of the status method I have up
all
there.
Of these above. Break.
Yeah, that controls all those different pieces to it, and then I one of the methods that you need is send from the interpreter, and it will allow you to then send actions or events to the machine itself. So that you'll see, like the radio switch and the light switch are the events I send in. So if you click show, look at the actual visualization of it.
Yeah. Okay. So all right. This is our. We are unplugged, and I'm going to then follow the flow we've been doing. We plugged it in, and I'm going to turn my radio on, and I like this sentence you have at the top. So what I'm going to do now is I'm going to unplug and test to see if you built in the history. Unplug, plug in.
Ta-da!
Ta-da! Okay, this is really.
All I did was just grab the state of Yep, I just grabbed the state from the machine and.
Yeah, you're never messing with the state. You're just.
Yeah, it's really.
Yeah.
I don't have to keep track of anything. I'm not updating flags or making sure variables.
Wait, this is so cool.
Yeah, that's what I said when I first finally got it. It was like, it just
Yeah.
it makes complex UI scenarios so much easier to sort out and fix. Otherwise, I mean, it's you're in this constant nest of
always
updating states and making sure they're right, and this is just you're sending an action and it knows what to do.
Yeah, I love it. I think it's just it makes it you set it up at the beginning, like we were saying with David, that you design it, create it, and then you kind of get to forget it, and then you just build the other complexities of the app itself, but the state piece is managed. And it's also funny because when we were setting up to do this stream, you were like, okay, we're going to go, overview of it, then we're going to do a diagram, then we'll like dive into actually build it. And I was like, there's no way in hell that we're going to get this done in an hour and a half.
It sounds like a lot. It sounds like a lot more than what it really was.
100%.
Yeah, it's the concepts are pretty quick to pick up on. You just have to take a minute and dig through them. But
totally.
But yeah, so let's see, a couple of good links. The XState.
Yeah.
We should get them to XState.
I sent the xstate.js.org. And I'm trying to think of what else there is that we want to send to folks for if they want to like begin their journey.
Definitely XState Visualizer, but the XState documentation for it, which is the same thing, just /docs.
Oh, okay, yeah, it's just like we didn't never even look at the docs actually, did we? Because you were giving me the verbal version of it, I guess. Which is awesome. Yeah, that's very cool. So cool. Then let's see. What am I trying to do right now? I want to send you all a link to sign up for Vonage if you haven't created an account yet. I have a unique code, or not code, URL for us to track the metrics of things. That's to sign up. Oh, that's not how you spell that. Sign up for Vonage. You get 2 free Euro credits when you sign up, but then we also have a unique code. Where am I in the chat? Right below, beneath me right here. Grab that. It'll give you 10 more Euro credits to play and build, and this could be super fun for you to play and experiment with, and join us on Tuesdays. We have some really exciting things happening in the world of Vonage this week. Tomorrow we have a big announcement coming, so pay attention in the world of our Twitter, our community Slack, and then we also have a full week of streams as well. We have Low Code Hour tomorrow, and Friday we have the Late Night Build with Michael Jolly, and then we also have a brand new stream that we're debuting on Thursday, which is a rotating ad hoc stream where different people on our team are joining, and we're calling the series New Stream ... Who Dis, and every week it's going to be a different kind of episode or show, and this week Noreen Jalal is going to be talking about how we create our YouTube videos for our tutorials and whatnot. So lots of cool things happening in the world of Vonage, but I'm trying to think of what else there is. Kelly, can you think of what we
Yeah, I did send you in Slack the blog post that I wrote.
That's what it was. I knew there was one more thing I wanted to share. Yes.
Which I think might be interesting too, and I'll help them, put this into a context with like a very complex video application, which is coming out soon. I can also send over. Let me actually send over the GitHub repo for it, the actual code itself.
Yeah, and that's probably in the tutorial, but
it's not this one. It'll be in the next one.
Oh, for your part 2, all right? Did you say?
But it'll give everybody here a little preview of what's coming up with it, so they can see. Yeah.
We got a lot of exclusive tidbits today. This was so fun.
Great. Yeah.
Yeah, I totally enjoy having you. You are a natural educator. That was wildly fascinating. I mean, you had it it's just translating it to the verbal. That's such a skill in itself. So I really appreciate it.
No, it was fun. I'm glad I could be here, and I mean, there is so much out there to learn, and understand about, state machines and XState.
I'm a big fan.
You'd be busy for days.
I'm going to start playing with it.
That's
Well, yeah, thank you for introducing me to it. And this state machine is one I'm going to continue building with. And if you in the audience, or if you're watching this in the future, start playing, let us know and join our streams and tell us what you're building, because we want to hear about it.
That'd be great.
But I think that's all for us now. Kelly, thank you. I will see you all very soon. Goodbye, live stream universe. All right, let's transition away and let's turn on our voices.